In this video, we're going to talk about some fancy exponents. Zero exponents, negative exponents, exponents that imply square roots. And in order to do that, we do need to recall a fractional situation, x to the a over x to the b. And if you remember, you did x to the a minus b. It is because of this rule that we can explain zero exponents and negative exponents. If we look at this example over here, as I said, I would normally just cancel and end up with a bunch of x's on the bottom. But if we use the rule, we would say x to the 4 minus 9. And that's going to get us a negative exponent. We're going to save this thought and see what happens in just a little while. First, let's talk about zero exponents. X to the 0 equals 1, by definition. That's what we were told growing up, and it made no sense until I saw someone actually do it out. If you have 5 over 5, we know that equals 1. Or 7 over 7, that equals 1 also. Or even x over x. Well, by using the rule of subtracting our exponents, if you have x to the 5th over x to the 5th, instead of canceling and making that just equal to 1, let's use our rule. X to the 5 minus our denominator, 5, which equals x to the 0. This is why it equals 1. A zero exponent implies that you had the same thing on the top as you did on the bottom. I want you to think about why x cannot equal 0 in this situation. Why the base cannot be 0. We'll talk about that in class. So we're going to go to our little negative exponent here. X to the negative n. What does this really mean? As I said, I would normally just cancel out all x to the 7ths up here, leaving me with a 1, and I would cancel out 7 on the bottom, leaving me with only 2 left. So this would become 1 over x squared. Well, if you do this using our rules of subtraction, we would say x to the 7 minus 9 equals x to the negative 2. Check it out. These two things are equivalent. So when you see a negative exponent, what it really means is that your variable is in the wrong apartment. It needs to be moved. So since this is in the numerator, we just need to take x to the n and move it down to the bottom. Another example would be if you had x to the negative 7 over y to the negative 2. Those negative exponents, again, they imply that your variable is in the wrong place. So these x's belong on the bottom, and they become positive now, and these y's belong on the top. And that is all that you would do. And now for some very, very new information. This is where it stops being a review. X to the 1 over n just means that you're going to have some sort of a root, a square root, a cube root, a 10th root, who knows. What this really means is x to the 1, that's what that little 1 on the top is, and the n is out here. So if you had something, some examples would be like x to the 1/2. That x to the 1/2 means it's just saying it wants the square root of x. All right? If you had x to the 1/3, it's saying the cube root of x. You can put the little 1 there if you would like. That's what it's saying. So when it's 1 over something, it is the root of that. So what happens when there's something on the top besides a 1, as in x to the a over b? This is nothing to panic about. If you already are thinking about the above problem as x to the 1 square root of, or x to the 1 nth root of, this is going to make sense. The numerator is the exponent, the denominator is the root. It works like that. So try this one out. If we had x to the 3/2, I want you to think about what that would look like. Who's going to go where? So we're going to say x cubed first, all right? So we're going to write x cubed, and then the bottom number is the root. You do not need to put a 2 there if it's a square root. It's the only root that doesn't need a number. But I'm putting it there just so we can see what happened. This would imply later that you could take something out here. You could actually take a square root and there'd be some leftover parts. Let's try just one more. X to the 3/4. See if you can set that up. And here it is, x cubed to the 4th root. And that's what's going to happen. It's going to get crazier where we combine all sorts of interesting exponents together, and we just need to be able to go back and forth from radicals to exponents so that it makes sense. I'll see you in class.